Welcome to GATE lecture video. I am S.A.E.C, Associate Professor, Department of Mathematics. I am going to discuss with the uniform distribution. This is a GATE syllabus for Computer Science Department. In this thing, I am going to concentrate probability. In the probability, in particularly, I am going to concentrate on uniform distribution. This is a definition of uniform distribution. A random variable x is said to have a uniform distribution over the interval a to b if the probability density function PDF is given by f of x equal to 1 by b minus a if a less than or equal to x less than or equal to b, 0 otherwise, where a and b are the constant with a is lesser than b. This is the graphical representation of uniform distribution. So we have f of x is defined from a to b, then 1 by b minus a is a f of x function, that is what length of the interval between b to a. The other places this thing is will come 0. From this to this value 0 and the remaining places 0. This thing is alone the function valued 1 by b minus a. That is the thing is only is represented that this thing is nothing but the length between b and a, that is f of x equal to 1 by length of the interval a less than or equal to a less than x less than b, otherwise 0. The probability is asked from c to d, where c is lies between a and b, c and d is lies between a and b. Then probability of c and d is nothing but length of the interval c comma d divided by length of the interval a comma b, which is equal to d minus c divided by a minus b. While we are using this formula, while we are using the problem, next, characteristics. The uniform distribution symmetric, a is equal to minus b, otherwise it is skewed. This thing is I will explain in the next slide. It is assigned on equal probability density all the value within the interval. The cumulative distribution function of the uniform distribution is f of x less than a, this value 0, a to b, x minus a divided by b minus a, in between a and b. Then above b, this value will come 1. The symmetric is represented here, minus b to b, this curve is symmetric about y-axis. But if it is there, a comma 0 is some other represented, this thing is will come skew. Sometimes this is x-axis, this is y-axis, means we can have this thing is also is a non-skewed one. It's not only this side, it may be is like this, either this side or that side. Okay, this thing is symmetry. This one is a symmetry, this one is a skewed one. Skewed one means as not symmetric about y-axis. Next, mean and variance and uniform distribution. The mean formula is a plus b by 2. A is nothing but the starting interval value, b is the ending interval value. Then e of x squared is b squared ab plus a squared divided by 3. The variance of x is b minus a the whole square divided by 12. So e of x means you already know. E of x equal to integration minus infinity to infinity x into f of x dx. Here is our function value from a to b, x 1 by b minus a into dx. So 1 by b minus a is a constant term. If we are integrating this, x squared by 2, limit is a to b. So 1 by b minus a. So if you are putting upper limit b squared, lower limit a squared divided by 2, then this thing is nothing but 1 by b minus a. This can be written as b plus a into b minus a divided by 2. If I cancelling this and this, we can get b plus a by 2, that is mean. Similarly, we can find e of x squared as b squared plus ab plus a squared divided by 3. From this, variance of x is nothing but e of x squared minus e of x the whole square. By using this formula, we can get it variance of x. Variance of x is b minus a the whole square divided by 2. These formulas we are going to use in the problem. Next, application of uniform distribution is it a modeling equally likely outcome, for example of rolling fair die. So 1, 2, 3, 4, 5, 6 it will come for a rolling. Simulation, uniform distribution is commonly used for simulation and Monte Carlo methods. Statistics testing sometimes used for as a null hypothesis in hypothesis testing. Discrete uniform distribution. This thing is usually we will do with the continuous only. Sometimes discrete distribution is also there. So understanding the uniform distribution is a fundamental probability and statistics. Especially in modeling scenario, where all the outcomes are equally probably over a defined range. This thing is we will discuss with the example. Here if you are tossing a coin, then the probability mass function of head is will come either 0 or 1. If it is 0 means the probability is 1 by 2. Number of head is 1 means that probability is also 1. That thing is represented in the diagram. For 0 is of 1. Here is look at all the probability values are equal. That's why this thing is what a discrete uniform distribution, because 0 and 1 is a discrete values. So I'll give another one example. So by rolling the dice, the probability mass function is shown up. Shown up in the face shown up is usually dice 1, 2, 3, 4, 5, 6 value. Each thing is probability has 1 by 6, 1 by 6, 1 by 6. That is represented in the diagram. Look at this, all the probability values are same. This thing is called discrete uniform distribution. This thing is not that much important. Is it a simple concept? This thing is already deal with the probability part itself. Next, so we are going to deal with the problem. The melting point of the certain specimen B assumed to be a continuous random variable, which is uniformly distributed over 110 to 120. Find the density function of x, mean of x, variance of x, and probability of 112 less than or equal to x, 115. So we already know the function f of x is 1 by length of the interval a comma b. This is the definition we already seen. From this the interval is given, that is what, 110 to 120. Therefore this
120 minus 110.
thing will come as 1 by 10. This value from 110 to 120, the other value is 0. Next, so we want to first mean. There is a starting value, a value is 110, b value is 120. The mean formula just now we have seen in the earlier slide. A plus b by 2, is it 110 plus 120 divided by 2? Is it 230 by divided by 2? Is it 115? The variance formula also we already seen in the earlier slide. B minus a the whole square divided by 12 is equal to 120 minus 110 divided by 12. This thing is the difference of this thing is 10 squared divided by 2. This 100 divided by 2. If you are cancelling 4 table, A4 table, this value 3 times, this value goes 25 times. Therefore answer is 25 by 3. Then finally they asked to find probability of 112 less than or equal to x less than or equal to 125. This value lies between the interval 110 to 120. Therefore probability, this formula we already seen in the earlier slide. Length of the interval is within the interval c comma d divided by length of the whole interval a comma b. Here is the required interval is 112 to 115. The entire interval is 110 to 120. Therefore the difference between these two is 3. Here the difference between these two is 10. Therefore the answer for this thing is 0.3. Next, x is a continuous random variable with the probability density function f of x equal to 1 by 4 if minus 2 to 2 and f of x equal to 0 elsewhere. Then the expected value of x is, this thing is asked. Next, here is the expected value formula we already seen in the earlier slide, a plus b by 2. Here the a value is minus 2, the b value is 2. Therefore the expected value is according to the formula minus 2 to plus 2 divided by 2. Minus 2 plus 2 is 0, 0 divided by 2 0. Therefore the answer for the sum is C, 0. Next, the standard deviation of the random variable of the uniform distribution over the interval 2 to 5 is where 4 answers are given. We will check which answer is correct. That is according to the formula for this variance of x is b minus a the whole square divided by 12. Here is a value is 2, b value is 5. Then according to the formula, b instead of we are substituting 5 minus 2 the whole square divided by 12, which is 3 squared by 12, 9 by 12. If I cancelling by 3 table, 3 by 4 will come. So here is they asked to find standard deviation. Standard deviation is nothing but square root of variance of x. Therefore, the square root of 3 by 4 is nothing but square root of 3 divided by 2. So this answer is A is correct. That's why next fourth question. The probability density function of evaporation in E any during year in a lake is given by f of x equal to 1 by 2, 0 less than or equal to u less than or equal to 10 mm per day, 0 elsewhere. Find the probability E lies between in 3 and 4, 7 mm per day in a day in the lake. Then there are 4 answers are given. We will check which one is correct. So here is they asked to find probability between 3 and 7. So this thing is also within the interval 0 to 10. Therefore, according to the earlier state formula, the length of the interval is the asked interval c comma d. The original given interval is it what? A comma b. It is 3 comma 7 to 0 comma 10. Difference between 3 comma 7 is 4. Difference between 10 comma 0 is 10. Therefore, the answer is 4 by 10. Therefore, the answer D is a correct one. Then fifth question, assume that the traffic junction is a cycle of the traffic light, 3 minutes of green vehicle does not stop and 4 minutes of red vehicle stops. Consider this arrival time of the vehicle at the junction is uniformly distributed over 7 minute cycle. The expected waiting time minutes for the vehicle at the junction is asked. So I'll explain this problem before we are going. Look at this, set 0 to 7 minutes. Okay. In this 7 minute, the first 3 minutes, then the remaining 4 minutes, we are divided into this thing is 2 part. The first 3 minutes green lights are there. That's why vehicle no need to stop, vehicle can go. Okay. This portion vehicle can go. In this place vehicle can stop because red signal is there. So here is but this thing is we are divided into 2 parts. X is uniformly distribution 0 to 7. Why it is 0 to 7 means 3 minutes green light, 4 minutes red light. Together is 7 minutes. This waiting and moving time together is arrival for one cycle. This f of x equal to 1 by length of the interval 0 to 7. This thing is 1 by 7. 0 to 7 alone, this function is varied 1 by 7. The other by it's 0. Then actually the problem is asked expected waiting time only is asked. This expected waiting time only is asked. Therefore, y is uniformly distributed over the waiting time. So here is waiting time is what? The last 4 minutes only is the waiting time because that is a red signal is there. That's why this function is defined by 0 to 3. The vehicles are no need to wait. That's why it's a 0. If it is the 3 to 7, red lights are there. The vehicles would be wait. That's a function is 7 minus x. Here they asked to find expected waiting time only. This is the important one. Then E of y is defined minus infinity to y into f of x dx. This value is divided minus infinity to 0 is 0. 0 to 3 is also this function is 0. 3 to 7 only the function value is there because there only is a green wait. That is what green light is there. All the other places 0. This thing is the first, second, last value 0, the middle value alone 3 to 7. Then y instead of the earlier slide we found 7 minus x. Then f of x is the entire function value 1 by 7 dx. So 1 by 7 is a constant term, that thing is taken out. 3 to 7, 7 minus x dx. If I integrating this, 7x minus integration of x is x squared by 2. If I are substituting upper and lower limit, 7 into 7 minus 3 minus 7 squared minus 3 squared by 2. So if you are substituting this, 7 minus 3 is 4, 7 into 4 28. Here here is 49 minus 9, that is 40 divided by 2. So 1 by 7 into 7 into 4 is 28. 49 into 49 minus 9, 40. 40 divided by 2 is 20. If you are subtracting this, 8 by 7 is there. That's why answer for this sum is A. Okay. Next sixth question. A point B is randomly selected with a uniform probability distribution in xy plane within the rectangle with the corners at 0, 0, 2, 0, 2, 3, 0, 3. If B is the length of the position of the vector of the point, then the expected value of B squared is, there are 4 answers are given. First I will explain the things by using the problem by figure. The rectangular thing is the 4 corners are given. The first point is 0, 0, the next point is 2, 0, here is the next point is 2, 3, the last point is 0, 3. This is the rectangle figure. Then here is given P is the length of the position vector of the point. So P we can take within the region. Here I am taken as this point is P. The horizontal value is x, vertical value is y. The distance between O and B, this origin to this P is root of x squared plus y squared. They have asked to find the expected value of B only they asked to find. Therefore by Pythagoras theorem, the P squared value will come x squared plus y squared. So we are going to find the expected value of this P squared only. Then x is given uniformly. X is 0 to 2 interval is there, y is 0 to 3 there. Let's say this uniform distribution function is f of x equal to 1 by 2, 0 to 2, elsewhere is 0. For y function 1 by 3, 0 to 3, elsewhere 0. Then expected value of E of x squared in the earlier slide we seen P squared plus AB by AB plus A squared by 3. Here is the B value 2, A value 0. If you are substituting this, 2 square plus 2 into 0 plus 0 square divided by 3, this value is 4 by 3. Similarly, if you are finding E of y squared, that B value 3, A value 0, 3 square plus 3 into 0 plus 0 square by 3, is it 9 by 3. So they asked to find the E of B squared. E of B squared is nothing but E of x squared plus y squared according to the diagram. This can be split as E of x squared plus E of y squared. E of x squared value 4 by 3, E of y squared value 9 by 3. So together will come as 13 by 3. Therefore answer B is a correct one. And the seventh question, x is a random variable with the uniform probability density function with the interval minus 2 to 10. For y is equal to 2x minus 6, the conditional probability P of y less than 7 given by x greater than 1. There is 4 answers are given. First I will explain the conditional probability. So there is P of A given B. Is it nothing but P of A intersection B given B. That means this event occur first, then afterwards the A event occur. That is a conditional probability. There is x is uniformly distributed minus 2 to 10. That's why according to the function that f of x is 1 by 12 between minus 2 to 10, 0 otherwise. Then the given value is y is equal to 2x minus 3. So actually the function given in x, therefore y we have to convert it in terms of x. That's why so the given value is what? Y is less than 7 is given. This y instead of we can write 2x minus 6 less than 7. If you brought it minus 6 this side, that will come 13. 2x equal to less than 13, therefore x value will come 13 by 2. This then probability of y less than 7 given x greater than 5 is given. So according to the formula for conditional, probability of y less than 7 intersection x greater than 5 given P of x less than or equal to 5. This y less than 7, the earlier slide we found x less than 13 by 2 intersection of x greater than y less than P of x greater than 5. Then so this actually so this thing is what this is a function is this thing is 0, here 5, 13 by 2 is nothing but 6.5, so 6.5 is there and nearby 6.5, here is we need below 6.5 then above 5, therefore we need the interval between 5 to 6.5, that thing is only is given. Probability of this is a common area between these two, that is 5 less than or equal to less than 35, given by probability of x greater than 5 means the entire function defined minus 2 to 10, but here is required above 5 only, here 0 is there, here 5, so between 5 to 10 only the final interval will come for this probability of 5 less than or equal to. So according to the earlier formula, the length of between 13 by 2 to 5, the bottom and the denominator one is the length of the interval between 5 to 10. So this thing is the difference between 13 by 2 minus 5 divided by 10 minus 5. This is nothing but 13 by taking LCM, 13 minus 10 divided by 2. This thing is 10 minus by 2. The subtraction of the above term 3 by 2 divided by 5, then 3 by 10. This is nothing but 0.3. Therefore the answer D is the correct one. Thank you. Continue in the next session.